In question 5, we have to prove that the circle drawn with any side of a rhombus as diameter passes through the point of intersection of its diagonals. So take any rhombus and take any of its sides, draw a circle with that side as diameter. We have to show that the circle must pass through the point of intersection of the diagonals. So let's first see a simulation that will help us visualize this situation, and then we will prove this result step by step. So here's a simulation in which ABCD is a rhombus, and I have this point X that allows me to move the rhombus around, change its size and orientation, and I can even move the vertices of the rhombus to vary it. Now let's take any of the sides of the rhombus. So let's take side AB as a diameter and draw a circle. So if I do that, I get this circle, and we can see that this circle passes through the point O, which is the point of intersection of the diagonals. And even if I move around the rhombus and change its size and shape, I can see that this circle always passes through the point O. Can you guess why? Can you visualize why this happens? Why this circle always passes through the point O? Well, the answer is actually very simple. The diagonals of a rhombus are perpendicular to each other. So no matter what the shape and size of the rhombus is, the diagonals of the rhombus are always perpendicular to each other. And we know that the angle in a semicircle is a right angle. So if you are using AB as a diameter and drawing a circle, then point O must lie on that circle, because angle AOB we know is 90 degrees. So this circle will surely pass through the point O. So that is the logic that is behind the proof of this current question. So coming back to the question, let's quickly write out the proof, the reasoning that we just discussed. So ABCD is a rhombus, and we will use the fact that in any rhombus the diagonals are perpendicular. So in any rhombus the diagonals are perpendicular, and this basically means that angle AOB must be equal to 90 degrees. Now this circle that we have drawn with AB as diameter, let's call this circle C1, and this means that if angle AOB is 90 degree, then O must lie on C1, right? Because the angle in a semicircle is a right angle, so O must lie on C1, and this means that C1 passes through the point of intersection of diagonals. C1 passes through O. So this is the simple reasoning behind question 5. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.